In today's video, we'll see a couple applications of the mean value theorem. A reminder of the mean value theorem is if we know that a function is continuous and differentiable, then we know that the slope between the endpoints, the change in y over change in x, must be equal to the derivative at some value in your interval. Well, they're saying here, what if we know f of 0 is equal to -3? So in other words, that means we have the point 0, -3. And your derivative is always less than or equal to 5. How large can f of 2 possibly be? So that means we're going to have the point 2 comma y. We don't know what the y value is. And that y is really our f of 2. We can use the mean value theorem to set this up. We know that change in y, so we're going to start with our y, the f2, minus our other y, the -3, over 2 minus 0, needs to equal our derivative. Well, because we know our derivative is less than or equal to 5, we know that f of 2 plus 3 over 2 must stay less than or equal to 5, because it's got to be equal to the derivative at some point. And what we can do is just solve for f of 2. So we'll multiply both sides by 2 to give us f of 2 plus 3 is less than or equal to 10. Subtract your 3 over, and you get f of 2 is less than or equal to 7. So we still need to answer the question, how large can f of 2 possibly be? Well, if f of 2 has to be less than or equal to 7, the largest that it could possibly be is 7. So 7 is your actual answer to the question. So if I gave you this on like a quiz or test, and you wrote f of 2 is less than or equal to 7, you would lose a point because that's not your actual answer. You haven't said how large it can possibly be. 7 is the largest it could be. Looking at another example, we've got f of 1 equals 4. F prime of x is less than or equal to 3 now. What is the maximum value of f of 8? So pretty similar idea. This is saying we have the point 1 comma 4. We have the point 8 comma y. Okay, this y is our f of 8 is a y value. So we'll do y minus 4 over 8 minus 1 must be equal to your derivative at some point. But we know our derivative must be less than or equal to 3, so we really know y minus 4 over 7 must be less than or equal to 3. Same idea as before, multiply both sides by 7. Add the 4 over. And actually, I'm going to switch this y back to f of 8. Okay, you're welcome to leave it as y if you want. Add the 4 over, and you get f of 8 is equal to less than or equal to 25. So what is the maximum value of f of 8? Well, if it has to be less than or equal to 25, the largest it could be is, in fact, 25. Now, the mean value theorem can be used to prove some different results. One of them is the following. If your derivative is equal to 0 for all x in the interval, it means your function must have been constant. And that makes sense. If the slope of your tangent line at every point is going to be 0, it must just be a horizontal line. It must be a constant. We are going to use this theorem number 5 in the next question. We are going to prove that this identity is true. What it means to be an identity is that no matter what x value you plug in, you get the same thing back. We're going to call f of x tan inverse x plus cotangent inverse x. We'll take the derivative. You should know the derivative of tan inverse x. It's 1 over 1 plus x squared. Cotangent inverse's derivative is just the negation of that. So it's minus 1 over 1 plus x squared. Well, that's just something minus itself. So we know that f prime of x is equal to 0 always. Well, flipping back here, we just said if f prime of x is equal to 0 always, then f must be a constant. So we know, therefore, f is constant. Because it is constant, that means we can plug in any value for x and find out what it will end up equaling. So we are going to use the x value of 1. And the reason being because in a 45, 45, 90 triangle, both tangent and cotangent have the same value. It's 1. Opposite over adjacent and adjacent over opposite are both 1. So what tan inverse is saying is it's saying what angle has a tangent of 1? Well, it's easy to think about in degrees, so it'd be 45. But remember, we have to work with radians. So if we convert that to radians off to the side, we'll get pi over 4. So pi over 4 is the angle whose tangent is 1. Pi over 4 is also the angle whose cotangent is 1. 1/4 pi plus 1/4 pi will give you a half pi, which is pi over 2. And again, we could have plugged in any value if we had wanted. The reason being because we showed that it must be a constant. So therefore, whatever we plug in, we should have gotten pi over 2 back. That's all for today's video. We'll see you next class, period.